Hi learners, in this video we are going to see some more intensity transformation function. Last class we have seen about three different transformation function. So similarly here also we are going to see about another transformation function. So before that just once again I explained this g of x comma y equal to t of f of x comma y. So here f is an input image, g is output image, and f of x comma y is the intensity value in the particular position x comma y. So just we pick the intensity value of that position, do some transformation function and store it in the same position in the output image. So that is the intensity transformation functions. So here in this video we are going to see about a piecewise linear transformation function. So here three different categories in this linear transformation, that is contrast stretching, intensity level slicing and bit-plane slicing. In contrast stretching, just here we are going to stretch the intensity value. So here in each intensity value we are going to apply this formula. First we have to take the minimum value of the overall intensity value in the image, and then maximum maximum intensity value in the overall image of the overall intensity value in the input image. So apply this formula, that is R is the input value of each pixel. Suppose if we are going to take a 2, 2 value, then R is the intensity value of that position. Subtract this R minimum value from this value into 255, and then R max minus R minimum value, and then you have to store it in the S. So using this S you have to create a new image, new color, and then store it in that particular position. So here what happened here is, so this part, this is a original image, and here after converting, after applying this contrast stretching, we are having this output image. So what happened here is we are stretching the intensity value. So here that is 0. Suppose we are having, this is our intensity value, 0, 10, 20, 30, 40, 50 and then 255. So this is our intensity value. So here uniformly we are distributing the intensity value. So this 10 become a 50, 20 become 100, 30 become 150, 40 become 200 and 50 become 255. So here uniformly we are stretching the intensity value and make it more visible and more comfort for our applications. And next we are going to see about the next level is intensity level slicing. So here we are having a two approach. One is, first we have to select the range in by intensity value between the some range. That is, if it is from maybe from 100 to 150. So in the first approach, suppose A is our intensity value minimum lower range and B is the maximum range. So in between the value we have to higher the intensity value. Just increase the intensity value only within this range. So what are remaining, just lower the intensity value. So only we have to highlight the intensity value within in this range, and remaining value we have to lower the value. So what happened is the region which we are interested become highlighted. And another approach is leave the remaining value as it is and only highlight the increase the intensity value of our area of interest. So that is in which range, we have to focus, that we have to increase the intensity value of that range. This is the second approach. So this is the output. So this is our original image. So only within the range they are increasing, other values become lower, and here just keep the other value as it is, and then increase only the highlighted area. This is mainly used for highlighting the interested area in the image. And third part is a bit plane slice. Third transformation function is, next transformation functions in the piecewise linear transformation is bit plane slicing. So here what happened is, suppose our pixel value is 1 or 2. Make it as a 8 bit. So this is the 8 bit value for this one. Convert into a binary value. So this is the 8 bit representation of the value 1 or 2. So here we have to create an 8 image using this binary value. So this is a 0 position, bit 1. So you have to put a 0 value in that position. If there is a 1, so this is a next position. So here we have to put a 2. If it is a 1, you have to put a 2. And here also we are having a 1, and then we have to put a 4. Because 2 comma 2, 2 power 2, 4. Here 2 power 1, 2. And then 2 power 0. Here we get 1. But here we are having a 0. So I put a 0 here. But here 1. The binary representation value of second position, the value become 2, and then here 4. Similarly here 0, and here the 16, we cannot put 16 because the value 0 is there. And then next here we are putting the 32, and then another 1 is there, so 64 and 0. So similarly, just we are splitting the value and make the image, single image as a 8-bit image. So this is for highlighting only the, used for highlighting only needed features. So this is only the contribution, just we can highlight the features, highlight the pixels which is contribution to the image. So the high order bits are usually contain more visual. So here when you see, so this is a higher order bit. So the higher order bit is having a more visual, because 1 will get 128. So this is our original image, and this is 0 bit 1, 2, 3, 4, 5, 6, 7. So here this is a highlighted value because we are having a either 128 or 0. So higher order is always highlighted, and lower order always very low in the intensity value. Another example, this is also another example. So this is our original image, make it as a 8 images. So this bit plane slicing, and then contrast stretching, and then intensity level slicing. So these are also one of the intensity transformation functions, comes under the piecewise linear transformation function, used for pre-processing the images. So it depends on our application, we have to select which transformation function is more suitable for our image. Thank you.